Everybody has these big questions. Where are we? Why is our universe as it is? To actually find these questions, you have to dive into this very abstract mathematics. At some point, all intuition is lost. You have to go into this very foreign and a little bit hostile world. I started as a physicist, but then I lost interest. I moved into painting because that really captured much more my imagination. While I was in art school, I started reading physics books just for the fun of it. I like to say that going through this detour of painting, for me actually was a shortcut to physics research. The connection between art and physics is really the research component. It's about what you don't know, it's what you want to explore. It's also failing and trying again and step by step finding your way forward. My own research always been concentrated on the interface of theoretical physics and mathematics. I've done work computing the number of states in black holes. Turn out to be captured by very deep mathematical formulas and have symmetries that are totally not obvious when you first look at it. Another field I've been working on a lot is the applications of random matrices. Matrices are mathematical objects that you see everywhere in quantum mechanics. If you take a particular perspective on these matrices, then in a very natural way geometry appears. In fact, we were able to recover the theory of algebraic curves, which is a beautiful mathematical subject. And I think this is a recurrent theme, that there is a way to extract geometry out of quantum systems, very much in the way that everyday physical properties of matter are emerging from the microscopic properties of atoms. In some ways, what we're doing is trying to find the atoms behind geometry. The way to the big picture is actually the small details, the actual calculations, like little stitches in this big fabric. I remember in 2002 I was working with Robbert Dijkgraaf at Harvard about random matrix models, and I had to take a flight on Monday morning and checking my email just before the flight, and there was a one-line message from my colleague saying, well, I tried this calculation and it seems to work. And it's a very short flight, only 45 minutes. I kind of worked out the whole theory during the 45 minutes. And indeed, I think we almost wrote the paper that afternoon. Sometimes the equations you find are much more clever than you are yourself. 2 years ago I was asked to become the director of the Institute for Advanced Study, and for me that has been a terrific experience because it allows you to combine three things. One is your own research. Second, you also see what's necessary to create an environment where others can blossom. And the third component is that you have to explain to the world outside why this is important. We have learned the last 100 years how to describe the world in terms of space and time and particles and fields. And these might all be just approximate concepts. There might be a whole new period. And I think actually we are right on the threshold of this. People ask me, why are you interested in these small particles? Like this is some exotic phenomena that only find in big accelerators. I said, wait a moment, where are you made of? You know? We are all collections of these particles. It's actually the thing that we share. It's about our history, not just of our own lives and of our parents and grandparents, but all the way down to the Big Bang and all the way down to the far future. Everybody who's alive right now should have some understanding what our idea of the cosmos is, of what we know and what we don't know, and what this reality is that we're all part of. It's actually our universe.